Hi, I'm Sifi. I talk to researchers about what drives them and what they're passionate about. What's your name and what are you currently studying?
My name is Prabhat Prakash, and I currently work at Caltech as a postdoctoral researcher. And I work on mostly chemical physics problems that solve issues related to carbon capture and sometimes high energy materials and some other times battery materials also.
What's your process when you're trying to learn something completely new?
I think the process is basically to break it down to small fragments, several pieces, and I try to familiarize myself with those pieces. Turns out most of the times when you bring it down to several pieces, some of those are already familiar to you, and then there are some new things which you have to learn. So basically, deconstruction and reconstruction is a sort of the way which I prefer to do.
Is there any method for deconstruction that you use? Like if it's a big topic, how do you deconstruct it?
So it can be either foundational based, that is what is the simulation part of it, or what is the theory part of it, or what is the experimental part of it. That is one way. What I prefer more is what I know and what I don't know. So if there is a complex problem, I try to come up with keywords which I know and the keywords which I don't know, and then I process there. Now there is evolution of these chatbots, so of course those are there, but earlier I generally have my own database also with the papers and presentations, and I had this hobby when I was a PhD student. I had this hobby that I would collect all these presentation slides from various topics, different presenters whom I liked, and sometimes it was way too diverse, but I would still collect them, and then that database now works as sometime like it can do wonders, because you can use these chatbots to search particular keywords, and then it gives you all the PowerPoints or PDF files associated with it.
That's very nice. Which single habit do you think has contributed most to your growth?
I did not have any when I was studying. Much later in my PhD time, I realized that I was working on more than one problems. And then one of my friends told me that it's always good to take one thing at a time. And that has contributed a lot, because sometimes what happens that if you are working on two different problems, one of them for the shop and other one for the soul, then you keep on distracting yourself from doing one thing and then distracting yourself to doing another thing, and then coming back and going back and forth. And in that process, sometimes you start second guessing also, particularly if you are failing in one of those. So in order to recover from that, it's always better to look at one thing at a time, at least for a day. These days, more than doing anything, I think I would say that significant portion of my time goes into convincing myself that this is the thing I want to do for the next few hours, or at least for the next few days, maybe for the next few weeks. And once I make that determination, then I leave everything to the willpower, if I can, manage that. If I don't do that, then probably I am not putting that much will, that much effort, and then I sort of give myself negative points that okay, this is not what I should be doing.
Can you walk me through your process of coming up with new ideas and keeping your creativity alive?
So these days with new ideas, generally you have vast literature and vast knowledge base also, with the amount of knowledge which is floating around. So it becomes very difficult to come up with something very original. Probably the best source of new creative ideas, the books and research articles and even review articles and their last sections, because generally those last sections are written with the problems which have remained unsolved. So if it comes about devising further problems or trying to do something novel, then those things help. In terms of doing something in your own work where you have to basically implement a new idea, I generally detach myself for a bit, go for a walk. Earlier I used to go to beaches, because I would just sit aimlessly and think about whatever else is going on in my life, and then I will try to bring that topic back, sometimes purposefully, sometimes without even purpose, and then sometimes that helps in getting some new idea.
What drives you to keep learning even when things get challenging?
Again, I was talking to one of my other friends a few weeks back, and that is basically engaged detachment. So I coined that word. I don't understand that well the meaning of both the words, but I can tell my own explanation how I see that. So engaged means that you are still in touch with that thing because of the boundaries. Like you cannot just give off on something, some project or some particular work, because sometimes there are commitments which have to be filled. So there is engagement which you cannot. And then detachment. Detachment is about the outcome. So you generally stop thinking about that what would be the outcome of this particular thing, and then keep yourself engaged with it. And that sometimes helps you in recovering from the successive failures. Detachment from the failure, and it is the most difficult thing to do. Often what happens that if we try to detach ourselves from something, we also disengage from it. For me, engagement is more formal sort of relation with something, and attachment is sort of a more emotional relation with something. So I try not to be emotionally attached to the thing which I am doing, because if you do, then the results start affecting you, and then you probably, if you are not lucky, then you would start self-guessing yourself.
What's a project you're currently working on that you're really passionate about?
So I work on several different projects, again for high energy materials, carbon capture, battery electrolytes. And in carbon capture, there is this problem where we want to estimate the concentration of ions in really small droplets. That is the project which I am more attached about, because it has a sort of subject matter history also, because the concept of pH, which people use in different things. Food items are controlled by pH. A lot of cosmetic products have pH regulations and whatnot. And the scale of pH is defined as a thermodynamic scale. So it basically is valid when you have a significantly bigger system size, like Avogadro number of atoms or something. But in smaller systems, like if you have a nanoscale droplet, you cannot define it. But ions still generate and regenerate themselves, or recombine themselves with each other. So that is something which goes back to my understanding of this subject matter from high school. And that is why I am more passionate about it, because it's really something which is very much related to the foundational knowledge of the subject.
Who is your supervisor and how have they influenced your academic journey?
So my supervisor is Professor William Andrew Goddard, the third. He goes by the name Bill Goddard, and shortly Bill, we just call him Bill. And he has been here for a very long time at Caltech. I think he would be completing, or maybe he has completed already 60 years since his PhD, and he was employed 1 or 2 years after it. So he would be completing 60 years here very soon. And now that I have told you the length of his academic career, of course he is, next year we will be celebrating his 90th birthday. He works for more than 70 hours a week. And he is probably, like we have roughly 20 to 30 group members in our group here, and he is probably the members who comes earliest than anybody else and leaves after anybody else. So and he keeps himself very much driven about it. He takes updates on everything here and there. So his professional and personal both commitments about science is something which has made a huge impact on me.
What's the best advice someone has given you?
My PhD supervisor gave me one advice. He said that when you are yourself calm or not too much excited, generally the flow of thoughts is much better. One single piece of advice, like to be calm and not to be affected by either success or failure much. So that also goes back to, by the way, the engaged detachment part, that you keep yourself engaged, but don't attach yourself to failure in that case, but even success.
How do you typically find yourself meeting new people around campus?
I'm generally excited about any of the seminars which happen cross department also, but if they have some sort of common scientific or philosophical interest, then I go for them. Earlier I used to organize this Caltech postdoc launch at campus, where I used to meet 1 to 2 postdocs every 2 weeks who would talk about their research work in a cross-disciplinary audience of several postdocs. And then there used to be lot more, they don't happen as much now, but there used to be lot more postdoc socials earlier when I joined Caltech. So I think from 2022 to early 2025, there used to be a lot of socials, and in those socials I would meet people, and I will get a good chance to interact with them. I am bit exploratory. I would rather go to meet cross-departmental people. When I was very new here, I would even go to other colleges also. Like if there is some sort of event happening in USC, UCLA, or even one of the most closest to ours is Occidental College. And I would go there and I would just try to talk to more and more people. I think that also improves on the things that you are living sort of alone, like away from family and friends. In this particular career, you don't have luxury to have the same friends over a very long period of time, at least not in the physical presence of theirs. So it's very important that you keep moving and keep finding new people to talk to.
How do you see the relationship between working hard and working smart, and how do you personally navigate that balance?
I consciously try to work smart, but I always realize that there are a few things which you cannot circumvent, and you have to always come back and work hard.
What do you do after accomplishing a long-term dream? How do you figure out what's next?
First time when that happened, which was probably one of the last projects of my PhD, I felt very excited, and for the next few days I was just chilling around, and then it was a bit difficult to come back to doing this. But over the time again, that engaged detachment has made me realize that okay, if something is moved forward, nowadays probably I would have a dessert and a few hours of binge watching a web series or a movie, and that is good enough. In last 3-4 years, I am not getting time to figure out the new thing because there are projects which keep on coming naturally, and which is sort of a good headache to have. Or yeah, maybe one day I will again start thinking about what to do next.
What are the primary sources of funding for your research?
So for this microenvironment work, which I work on the carbon capture problem, there is a Department of Energy hub at Caltech, which is called Liquid Sunlight Alliance. There is another building near Red Door, Resnick Sustainability Institute, RSI, and there is this Liquid Sunlight Alliance, goes by the short name LISA. And that is a DOE hub which comprises like several tens of faculty from Caltech, Berkeley, Stanford Linear Acceleration Center, and then Oregon, and then some from Irvine. So there's a good collection of those PIs and who work on different parts of this problem. Some people work on the simulation part, some on theory, some on the interface of that, and of course there are several experimentalists, including the director of LISA, Harry Atwater. Good collection of people, and that is the primary funding source for me.
In what ways do you see your research making an impact in this world?
Particularly after joining Caltech, this is one of the wonderful things which happen at Caltech, that we generally have these seminars where we get to hear a lot. So when I started working for LISA, I had idea that okay, we are making these liquid fuels from solar energy, but how impactful it was, that I realized from several of the presentations which we had over the years from Harry Atwater or Francis Hole from Lawrence Berkeley Lab, and it's really nice to be part of those discussions and those presentations, because suddenly you realize that the tiny things which you are doing on a computer are directly connected to solving the problem of carbon conversion. And it's well known that carbon is the end product of all the processes, carbon dioxide, so to speak. So to convert it back to methanol, ethanol, or even methane is something which is very important. So that is one part of it, which is basically dealing with the end product of the energy cycle and bringing it back to becoming more useful. And the other part is of course energy storage problem. And for that I have worked during my PhD time. That part I understood even then, that these lithium batteries or even the modern sodium batteries, solid batteries, and some of the alternative zinc and magnesium based batteries, those are the future for the energy storage purposes, and we have to make them more efficient and more safer as we progress further. In the world, there are very few batteries which can operate very efficiently in, let's say, in Delhi, where the temperature goes to plus 50 degrees Celsius, and then in Siberia, where it goes to, let's say, minus 60, maybe minus 50 degrees Celsius or so. So there is a wide range of temperature, and these both issues are sort of intertwined also at times, that the same batteries which are safer, they don't remain as efficient when the temperature conditions change, and those which are as efficient, sometimes they are not as safe because of the degradation of the electrolyte part of these batteries. Most importantly, anywhere you have carbon sinks in the form of carbon dioxide or bicarbonate, use electrical or solar energy to convert that back. Caltech is developing several cascade architectures and basically tandem electrode devices which have some of these concepts, in a sort of assembly where there is a photocatalytic converter with some sort of electrochemical electrode sort of device, and that basically can achieve the optimal conversion factor.
Right. Thank you so much. That was awesome.